maybe just a raise of hands. Who's non-engineer? And all the others are engineers? Great. So, yeah, about half and half. Cool. So let me tell you a bit about antivirus. Let me tell you a bit about KaChing and what we do so that you have enough context to understand why continuous deployment is so important to us. Our goal, our vision is to connect investors with investment managers. Most retail customers, and retail customer means someone who has less than $1 million of assets, don't have access to investment vehicles that are to the quality of hedge funds or other investments. And mostly people have access to mutual funds, which are not very transparent, are burdened with very high fees, and really have a structure that forces win-lose, where the manager is going to win a lot of money, but the customer is actually having his assets underperforming year after year. In that world, Schwab has created something called Schwab OneSource, which is the marketplace that is the best place to get access to mutual funds. And it's really an eBay, but for mutual funds. And what we're trying to do is create a marketplace for individually managed account, essentially bringing wealth management to retail. Some of the core principles behind KaChing are transparency. On KaChing, everything is fully open. You can know everything about your manager, and having win-win situations. We want to align interests to make sure that the incentives of the managers and the incentives of the customers are completely aligned. As you can imagine, we're operating in finance, where it's a very heavily regulated industry. We are ourselves an SEC-regulated company. We've been for the past 6 months under SEC examination. We're soon to be a broker-dealer and have an additional set of requirements imposed by FINRA. And so all of those things are kind of pushing on our processes and some of the interesting things that are that could have forced us not to be them. And we'll speak about why CD in that context was so important. The market we're in is huge. It's $11 trillion in the U.S. And every year there's $800 billion of assets that change hands because people are unhappy. Our business model is very simple. Managers on our website offer their services to customers, and they charge a management fee, 1% and 1.5%. We take a cut of that management fee. The second revenue stream is commissions. All of the trading that we generate for our customers generates commissions, and we are able to make a margin on that while providing about 5 times cheaper execution than retail brokers. Now, our vision has always been the same. We wanted to bring wealth management to retail and basically take what Ivy League endowments do and empower retail customers to have access to that. We wanted to have the transparency that the Ivies can command for retail. However, our strategy to get there has changed dramatically. Today, KaChing is a professional-only marketplace where registered investment advisors can offer their services to customers. The experience is you go to our website, you can open a brokerage account, transfer your money to KaChing, and that money will be automatically managed following the model of the investment manager that you choose, one or many. Now, we started as a fantasy stock exchange game on Facebook, and we attracted 200,000 users, really gamers, 15-year-old and more, who were basically playing on our system. And our hypothesis and the reason that we went completely virtual, with fake dollars, is that we thought amateurs could rise through the ranks and become pros. And we wanted to build a platform to enable vivid amateurs to turn into pros. And we also thought that amateurs who, using the same tools as their peers, underperformed the market would realize that they would be much better off giving their assets to those pros. It didn't really turn out that way, and we've done a number of changes over time. And so it's kind of interesting to see how you go from one point to the other. Now, something that's inherent in every startup is the tension between product and development. The CEO wants features, 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 and the CTO wants stability. We want to build the right architecture. Now, something that's interesting, and the reason I put right in quotes, is that there's really no right architecture. The right architecture can only be seen in the context of what is the purpose that this feature is going to entail. However, when you're iterating in a startup, you don't really know how your feature is going to be used, and therefore you cannot project yourself on what you should build. And as a result, there's not really a clear answer as to what is the build right philosophy. Now, something that we've always believed in is to do what we call proportional investing. When there's features that you want to get out, you want to try and invest as little time as possible up front, get it out as quickly as possible. And if things break, if things are not working properly, fix it and then compensate with exactly as much time as you spent working on the emergency or the production problem, improving that feature. Now, when you have 20, 30, 50 features, it kind of creates an ecosystem where you naturally balance your work and work on only the things that actually matter to your users. And it also enables you not to invest too much up front. A great example is monitoring. You want to have, your system is running as a 24/7 operation. Obviously, you want to have some feedback on how's the system working, but it's very hard to say where to start. What you want to do is, just let things break, and whatever breaks, go and monitor that. And it won't break anymore. And then something else will break. Go and fix that and monitor that. Improve in a very rational way. Now, we've also embraced Pareto very early on, which is very nicely captured as the 80-20 rule. 80-20 has kind of two sides. Obviously, you want to build 20% of the cost and get 80% of the value. But something that you also want to realize is most of the things you're going to build, and for us it was about 80%, is not going to make it into your end product. And so you don't want to invest too much time up front building things that are going to the dumpster. Now, if you do that, it creates two problems. The first one is that you won't be able, if you invest too much time up front, you might end up with an architecture that is rigid and that doesn't enable you to change quickly to go to where your users are asking you to go and where feedback is asking you to go. And if it ends up that this feature, this system is actually worthless, it's much harder to look at the facts and remove your emotions on, I've spent all that work on that feature and kind of move on. And this kind of happened in many, many occasions. To give you an example of the 80-20, when we launched a group feature, people could convene in groups and have kind of investment clubs on our website. We launched the feature in a way that, first of all, didn't scale past 200 members, and people couldn't even edit the description of their group. They could set it when the group was started, but then it was kind of set in stone and they had to send an email to support to be able to change it. Now, it turns out In about 1 month, 5 people wanted to change their description. People were much more interested in other things about groups than changing the description. So kind of cutting that corner really helped in spending our time on what actually mattered. Now there's, errors are very costly. Like it's really something that you want to avoid. I think that something to realize is continuous deployment for us and iterating extremely fast and turning the wheels on our software is something that we consider mission critical. It's not only a nice technology thing to have that's intellectually challenging, but really it's a way of operating our system. Errors have 2 costs for starters. One is brand, and the other one is simply SLAs. If you have people paying for your software, you will need to reimburse them part of your revenues if your system goes down. Now, in a regulated industry, the third aspect is liability. The kind of money that we are managing is much greater than the amount of money that was invested in our company. We are liable for trading errors. If we place a bad trade, we need to reimburse our customers. And doing those kind of errors can very quickly eat into our cash and kill the company overnight. And so continuous deployment, working in very small batches, iterating extremely fast, and having extremely high confidence into the production environment is key to be able to reduce the risk on the operations. I have friends who basically stop the world when they do a release. They have, every engineer on deck for a full day, and everybody is kind of, really crisp about getting that software out. On average, we deploy 20 times a day. It's really a non-event. So before we delve into continuous deployment per se, I just want to define what we mean by continuous deployment. It's really the successful and repeatable way of deploying code. It's very easy to take code and get it out and take the site down. What we want is to make it many, many times and do it successfully. And it's kind of a carefully crafted automation of every step between taking what developers produce and what customers are actually using. And we're going to see a timeline for all of the steps that we're speaking about. So this chart was taken from our deployment manager, which tracks every release we do. It was, from more than 1 month away, we're probably more in the 30 deployments a day now. We're adding more and more features to the deployment management system. And as we do that, the number of deployments kind of goes up. The easiest you make it for developers to deploy their system, the more they're going to do it. For engineers here, we added a feature yesterday night that allows engineers to put in their commit logs a hashtag, release : the name of the cluster they want to deploy, and when the build is done, it automatically deploys. On the side of having continuous deployment be mission critical to reduce risk, it's also, a key idea is separating releasing, which is unveiling new features, and deploying code. The engineering organization in a startup should be focused on making code that was developed by engineers work in front of customers. Marketing, on the other side, should be focused on timing the unveiling of new features. If the press launch is better done next Monday versus this Monday, they should be able to have a little button and just say, well, okay, now the feature is up. To take the analogy with a supermarket, continuous deployment is essentially filling the stacks one after the other while customers are in the store. You're not going to shut down the store, fill in the shelves, and then let customers go back. You want to do that exactly at the same time. Now, releasing a new feature, releasing a new product in the supermarket is, hey, opening a new aisle. Now, let's speak about how software is traditionally organized and how software organizations are working. Usually, the software is organized as a tree. Developers work on different branches of that tree. Trunk, the main line, is what is the absolute truth, and that's what goes to production. Engineers work on different branches. They're kind of isolated from the trunk. And when they're ready with their features, they're going to integrate those branches back into the trunk. Typically, in most web startups, there's a release train, every week, every 2 weeks, every 3 weeks. I've seen every month. And basically, there's cutting the release, taking that code and making sure that within a 2 or 3 week period, it's going to go in front of customers. Quality assurance in those organizations ensures that the code is actually correct. And makes sure that every train that attempts to go to production, and it's only an attempt, is actually correct and is not going to introduce errors. And P1 bugs, very high critical bugs that were discovered during QA, are going to be passed back into the train. So the developer is going to work on that bug, and then that bug is going to be integrated into potentially 3 or 4 week old software. And then, as we talked about before, you get the code out, and it's a flip the switch release. It's really everything goes out at once, and everybody is extremely scared of getting that new software out and changing everything at once. Now, here's how it looks from a timeline perspective. Development happens, it might take any amount of time to develop a new feature. Then there's cutting a release. You take what's on trunk, everybody's happy, the PMs are satisfied that they're going to get all the things they want, and a release is cut. To give you an anecdote, when I was at Google Checkout, it would take about a day to cut a release. And it was literally the program managers running around the office telling, to everybody, like, okay, please stop checking in code. Eric is going to check in code now because he needs to get his thing in. And then wait for the build to go green, it would take about 20 minutes. And then go to the next cube and make sure, okay, now you get your your code in. Then you need to stage the release. So you've got, this nice little train. You need to put it on a QA environment for, the QA team to be able to work on it. And, the QA team is very separate from development. They're really working on parallel tracks. QA, Google Checkout was taking a week. It can take up to a month. Then QA feeds back into developers, and developers are going to address the most important bugs. These bugs need to be fixed not only on the new version of the software, which is, by now, 3 weeks later, but also on this old train. So things need to be integrated back. And then the release. Now, this timeline is extremely wasteful. There's a lot of things which are disconnected, a lot of teams that need to synchronize on very, very rigid and wasteful processes. Everything takes about 1 to 4 weeks, depending on which company you're in. If you're in the government, it takes more like 9 months. So let's revisit that timeline and look at how continuous deployment actually achieves in changing the core of how things are happening. First of all, the software is always stable. There's not one single point where the software is not stable. To give you an idea at KaChing, if the software is unstable, the build is red, we have lights that go on, we have a penguin that actually announces that the build is broken. And so there's immediate response from engineering, and everybody is basically going to stop what they're doing and make sure that this very small change that just occurred gets resolved immediately. Now, because we do automated QA, or what we call testing, you don't need to stage a release. Your software is going to get automatically tested. Now, there's no need to fix P1 bugs because, as we said, the software is stable at every point. No need to integrate patches because you simply don't fix the bugs out of sync with development. And we don't release, we deploy. Releasing is marketing's concern. It's unveiling new features. Deploying is something that's continuous, getting code running on production. Now there's two things that we need to add to that picture that make it possible. One is what we call experiments. You might be working on the new homepage. It's not something that one developer can work on by itself. And so it's going to invariably get to production before it's ready. You must hide that behind experiments in order not to expose customers to a half-baked feature. And on the other end, you need to have an immune system or monitoring to be able to automatically look at your system. Now, monitoring, I would argue, is something that any web startup should have, be it lean or not. We operate in a 24/7 environment. Not knowing when things break is a major concern. And at KaChing, it takes about 5 to 10 minutes to do the whole cycle. Now, experiments is basically splitting features between users. If you're in the press group, you're going to get to see the new homepage 2 weeks before it's unveiled, so you can write your nice article. So in the code, it kind of looks like that. If you're in the experiment, we're going to show you that part of the code. Otherwise, we'll show you the other part. In practice, when you implement it for real, you want to use a pattern called the capability pattern. But this kind of captures the idea of what you're trying to do. And yes, this is just like A/B testing without the statistics. And so that's something that you should do anyway.
I have a quick question about that.
Yep.
So say you're doing like a sort of major change, like you want to completely change the way that people navigate the website, completely reorganize it. So you're going to use this approach. Do you just keep two separate tests, a set of test suites that has sort of both configurations?
Yes.
And is there ever an issue with some sort of like combinatorial explosion of, basically you have things that are like branches, and at some point you're going to have to still integrate by flipping that switch. So is the way that you approach that is to have tests for all of these different scenarios, and still have a point at which you flip the switch?
So that's a great question. Combinatorial explosion of those split features. Our experience at KaChing is that we typically work on we'll work on the new homepage or the new flow, and we still need to maintain the old one. So we basically have two things. We haven't had a lot more. Maybe we'll have 5 experiments. Now, when I was on the Gmail team, yes, there was exactly that problem because there were you all know the labs, and there was a number of other experiments to kind of try to do A/B testing. Overall, there were maybe 200 experiments, and God knows how many different states. So it can definitely become a burden, but for the purpose of continuous deployment, which is having both sites run in parallel, the new one that's only available for the team in development, and the current one for customers, you don't really get that aspect.
Okay, and the way that you do the testing is you basically just change that constant somewhere, so
yes,
everything
exactly.
changes wholesale.
Yes, the context in which this code is going to execute will enable you to put the user in one experiment or the other.
And do you feel like this in any way provides a disincentive to make large sweeping changes versus incremental changes when they're necessary? Or is that something you've even attempted where you say, this whole thing needs to be redesigned, this whole section of the site, this whole way we're approaching it?
Well, we've redesigned the whole website a number of times and really had 2 different versions of the website running in parallel. And so, no, I wouldn't say that it disincentivizes that. Now, we had one day an investment manager calling us and tell us, whenever I trade, I don't really get the kind of feedback that I expect. When I'm on Schwab or Fidelity, I get more precise feedback. It'd be great if you guys could do that. So we go back to the drawing board, do the change. It's a very little quick UI thing. Get it back out to production, and we can call him back. Hey, what do you think of the flow now? And this has happened many times. And being able to iterate in production with your user is something that's extremely powerful. Not only from the learning experience that you can get, but also in pitching your ability to cater to their needs.
A quick point of clarification. So what you're saying is that this is an experiment, and you would have made that feature, for example, available only to him, and then had him.
No, I want live production to everybody.
Okay.
It was great feedback. It's like, it'd be better if you showed the total in this way and added this and that number. We thought it was a good change, and we went ahead and did it.
The piece I'm not getting there, and I don't know if other people are, or you're going to get to it later, is how are you 100% sure that that improvement that you made isn't going to bring your whole site down when you deploy it? That's the piece I'm not.
That's a great question, and I'm going to speak about testing and monitoring right after.
Okay, cool.
So the benefits of continuous deployment, as I said, it reduces risk. That's I think, the number one. Obviously, the main purpose is to allow quick iteration and to change the wheels on the software. It obsoletes the need for processes, such as cutting a release or manual QA, synchronization between various teams. Reduces risk. It forces everybody to be aware of production. Engineers have to understand that their code is actually going to run on the website. And so it forces you from day one to take in consideration how your system is going to run within the production environment. And you can't really escape that reality. And with that, no one can throw code over the wall. In an environment where you have a QA department that's very separate, engineers tend to kind of throw their code and say, well, these guys are kind of responsible for quality. I'm responsible for building the feature and making my program manager happy. They'll make sure it's actually high quality for the user. It exposes the 24/7 operational concerns. There's whenever an engineer does a change, whoever the engineer, they cannot do a forward or backward incompatible change because there's no way that this change could go in production that way. And so it kind of puts that feedback extremely early on what you can do and what you cannot do. For me,
How do you take into consideration cases where you're making, I don't know what your backend databases are, make some database changes and you have two parallel releases which are kind of incompatible in terms of the model?
We never do. We never have incompatible releases. So everything is forward and backward compatible at all times.
For how far back?
As much far back as we are guaranteed not to have to roll back. So typically about 1 hour back. Which might seem crazy, but 1 hour is like potentially 15 releases, 10 releases.
But are you sure at the end of the day, like, the code you gotta go like at the end of the day, it's like great? It seems like it's still fun all the time.
Not really, and we'll speak about testing afterwards, which is really the essential part. Test-driven development is the foundation for being able to have that confidence in your code, and being extremely rigid about not developing code without a corresponding test really ensures that you don't get in a situation where one piece of code is actually not working or not covered.
So can I just follow on that? So
you haven't had a situation where you've got some border use case that that you built on for the last 2 hours, and you just discovered 2 hours later, oh crap, there was this outlier case, and we built on it 40 times now, and we
Well-
can't, and we in fact do need to roll back to
So,
try and fix that, or?
so yes, we do roll back. So when a release goes out, if anything is detected as abnormal, we do an automatic rollback. It takes about 8 seconds. So if a cluster is detected as being in a bad state, it'll roll back within 8 seconds, completely in parallel. So yes, we will take downtime, but a downtime that's much smaller than if a human had to look at that. Now, for the problem where you release something, and it so happens, especially in financial system, that you have a lot of batch processes that only run at night or only run on weekends, and so 3 days later, you realize that, oh, you didn't think about that case, and it kind of breaks. Well, at least you've got a system that empowers you to change things extremely quickly. And I think that you don't want to get stuck in a place where you cannot change that software anymore. It's too late, and you'll have to live with that bug for some time.
So is it fair to say that if you are in that situation where something breaks, rather than rolling back, you guys just press forward?
I'd say there's two situations. If we can roll back, we will prefer rollback. Mitigate the problem and think later. If it's too late to roll back, we will push forward. Yes. The next part is the immune system. Looking at the system in real time, exactly to be able to detect things that are abnormal. And continuous deployment is kind of the cherry on top of all of that. Continuous deployment builds on all of those different layers, and essentially, it's an integration between all of those different processes in one system. Let me speak about KaChing's architecture, and then we'll go into some of the technical implementation of our continuous deployment system. So our system is completely service-oriented. It's all based on the same platform that we call Koala, that is in the process of being open source. We only do vertical sharding. So basically, we split things by domain. The user management system, the portfolio management system, the real-time trading system, and shard that way. We use a system called Zookeeper to be able to organize the cluster as a whole. Machines need to be able to understand, who can I talk to? This moves a lot because machines can go up and down many, many times during the day. And the data interchange between the machine is language neutral. We use JSON and protocol buffers, which is essentially a binary representation that's extremely efficient, that was developed back in the days at Google. A typical stack for one of our cluster is going to be many instances of the same service, a replicated database, and we use a number of storage mechanisms, MySQL, Redis, etc. Some caching, memcached, and then denormalizing data if that's necessary, and we like to use Voldemort for that. So let's look at our timeline, our revisited timeline, and break it into the 4-section: development, testing, deployment, and monitoring. Now, from a development perspective, we are trunk stable. So every engineer works on exactly the same software. There is never a case where one engineer builds this really cool new feature that another engineer is not able to use for the next 2 weeks because they're both on different branches. We do very small, frequent commits, and so you will not get in a situation where you have 1 week worth of changes that you get pushed all at once. As we said, the unreleased features live behind experiment, which is a great way to learn about A/B testing extremely early. We're forward and backward compatible at all times to be able to roll back very quickly if problems arise. We have responsive code reviews. If I send a change, I can put in my commit message, please review this change. And an email will be automatically sent to the team, and a team member will give me an answer and a thumbs up or thumbs down on my change within the next 15 or 20 minutes. And we also like to pair on difficult problems. We'll sit together on a computer and spend 4 hours kind of coding and pushing ideas around. And finally, one thing that's extremely important is rolling back the system extremely quickly if something bad happens, to be able to mitigate problems very, very quickly. Our testing philosophy is that only testing matters. We don't rely on any manual QA. No one on our team does any sort of manual testing of the software. Everything is fully automated. If it's not tested, we don't consider it finished. And we will not commit code that is not fully tested. We also believe in writing testable code and making sure that from the start, we build the software knowing that it's going to be tested. In order to achieve that, we have to embrace abstractions. So for instance, if we need to write to the file system, we're going to go through an abstraction that fakes the file system to be able to very quickly test that. And finally, just like security, testing is cross-functional, and we all own quality. It's not another department or other team members. Everybody must make sure that the quality of the software is there at all times. The benefits of test-driven development, of making sure that as you develop your code, you make sure that it's tested.
Actually, one question on the previous slide. You were saying that all testing was automated?
Yes.
What about user-facing stuff? So the user interface, usability issues, that kind of thing.
Well, so there's two sides of quality assurance. There's one side which is making sure you build the software that feels right. And that's an inherently human function. But it's typically not done by the QA department. It's done by the program manager or whoever is the product driver. It could be an engineer, it could be a marketing person. This is something that's inherently human. Now, making sure that once you know that you've built the right feature, that it actually functions properly, that can be fully automated.
So is all the user interface stuff defined before your process starts? So I mean, what about changes to the UI midway through the development cycle? How would that fit in?
I don't understand the question.
Well, I mean, personally, I would worry about launching user interface changes without doing some testing. And
Do you mean user testing, like focus groups?
potentially, or some kind of QA, UX audits, that kind of thing.
Well, yeah, focus group and making sure you're building the right product is very different from making sure that it's correct. And that's, again, it's not engineering's function to make sure you're building the right product. That's more marketing and product development. And so these two things are quite different. Now, from a user focus point of view, you can actually create a new UI, hide it behind an experiment, either expose it randomly to 10% of your user space, which is A/B testing, or actually ask people to come in your office and interact with the software. Does that answer your question?
Sure.
So what about kind of cross-browser and cross-platform testing?
Yeah, so cross-browser and cross-platform testing. So what we do, very briefly, we have N front-end servers. We always have a spare one, which we call the canary. Before any release, we release to that canary. And we have automated Selenium testing that is going to check that this canary works fine. And then we go through the normal development, the normal deployment process that a backend system would have. exactly to address those kind of concerns. So basically doing end-to-end testing in production. And in our case, it's extremely hard to stage those kind of things because it's very data-driven. And so we want to be able to run end-to-end tests on production data on the live system. It just so happens that we have a spare machine on the side so that we can run it before it even gets to the first machine that serves live traffic.
I'm not sure I follow this. I mean, I understand that there's a live machine, a carrying machine. And then is the Selenium testing replicating XP IE6 patch 1 or something?
Yes.
Okay.
Yes. So Selenium is a great tool to be able to run essentially any browser on any operating system in a relatively easy way. You know, it takes some legwork to get set up, but it addresses exactly that concern.
So if you're going to get to it, that's great. But when you talked about data-driven and you put it into production because you want to test it, obviously yes. So when you roll back, you're rolling back the data as well in case there's data corruption? And if so, what do you do with the live data that's good that you collected?
No, we do not roll back the data.
Okay.
You know, if data cleansing is required, then that's going to be something manual.
Okay.
You know, it's again, it goes back in the mitigation part of the emergency, you know, it never happened that a release corrupted data. What has happened is some encryption, you know, had some concurrency issues and actually, you know, erased some of our records, and so we had to, you know, pull some backups and, you know, spend the day or so that it took to reinstall them, get those records, put them back. And you know, I don't see these things as specific to continuous deployment per se. You know, they're inherent in any production environment. Being able to detect that very quickly and again push a new change and address the problem almost immediately, you know, within the hour, is what is critical in reducing the risk of your operations. The benefits of test-driven development is, just like continuous deployment, moving very quickly. You want to have your engineers get automated feedback. You know, in the first year, I would go around and say to people, yeah, don't use this API, don't, you know, use that pattern, you know, it's not good, it has a bug. And so over time, we kind of encoded that as tests so that people get the feedback automatically. You know, on your first day, you try to do a change, you commit it, and you get automated feedback that, hey, you shouldn't use that. It really makes it possible for the engineers to change anything in the system. You know, even if you're not an expert at this or that domain, you know that you can go there, make changes with a confidence that other engineers before made sure to have the safety net of tests to let you kind of play around with it. It's much more effective than debugging. Now, what I mean is, you know, think about debugging a system that's live in production where you have absolutely no tools. Doing a test that is going to take you maybe 10, 15 minutes is much cheaper overall than spending one day looking at a live system in production that is behaving in a hectic way. No functional QA, as we talked about. And it makes it easy to refactor the code, which, you know, in turn makes it age well. And finally, you know, one very important thing is that it attracts the right kind of team. You want people who are passionate by that and who are going to drive to get really high quality software at all times. Now we're going to go quickly through the kinds of testing that we do. Unit testing, which is the lowest level, you know, does this very, very small little piece actually work? Integration testing, you know, take a number of components, put them together. Do they play well together? Regression testing, whenever there is a bug, make sure you write a test to ensure that this bug never happens. And then finally, front-end testing, which is really a different arena, which needs its own set of tools and its own set of techniques.
Is that usability testing? Like, what do you mean by front-end testing?
Front-end testing meaning does the front end actually work? So for instance, in our case, one of the key part of our website is signing up for a brokerage account. And there's a number of fields that you need to fill in. It takes about 5 to 10 minutes for a human to fill it in. We have automated systems that are going to go through that process for all kinds of accounts, an IRA, a Roth IRA, a rollover IRA, you name it, and make sure that all of those cases are still working. So it's not going to check that it's intuitive to a human, but it's just going to check that what was defined at some point in our product process as good actually continues to work. Yeah.
So you mentioned that the Canary is not actually in the staging environment, it's working on production data.
Yes.
So with these new registrations that you're getting, are you throwing these junk registrations into production data and
Yes.
you don't clean it out?
They're automatically marked as being testing data, and they get cleansed automatically. So for instance, they don't show the reports. They happen to be on the same database, but it's very siloed. Now, defensive testing is something that you get more and more into when you do test-driven development. It's, instead of making sure that you're doing the right thing, it's writing the safety net to make sure others are not going to break what you built your software on. So that I don't come in after my vacation and someone broke my feature and kind of broke how my view of the world and how my software had to work. And it's really making sure that helping others understand your feature better. And I think that we really see tests as kind of a live documentation of how the software is working. The implementation of our testing uses open source tools. There's nothing that's specific to KaChing. All these tools can be downloaded and are open source. Now let's look at the life of a deployment and how the deployment actually happens in a service-oriented system. So here we have a cluster of portfolio managers. It's basically one of the main accounting systems. The arrows on top are incoming requests from other machines that are asking to get this portfolio, do this trade, etc. On the left, we have the DM, the deployment manager, and on the bottom, Zookeeper, which does the cluster organization. It's basically the only place where there is global coordination between all of the machines. So the first step is going to tell to everybody in our production environment that the machine is going to go down. So we mark it as down in that system called Zookeeper, and everybody is going to stop sending traffic to that machine. Now the machine is still working just fine. It just so happened that it's not serving any more traffic because the clients are routing their requests to other machines. Then we can safely take it down with no disruption to the customer experience. Then we bring a new one back up. There's still no traffic to that machine. We have the time to do self-tests. So we're basically going to check, can the machine connect to the database? Can it get prices? A whole number of automated self-checking that the machine can do by itself. We're also, in that period, going to increase the frequency of the monitoring to make sure that it is not causing more load on the database than it did before, and that all of the metrics that we care about are still within bounds. And then we can release it and mark it as green, and traffic is now going to start flowing to it. And here, what's important to realize is we now have a heterogeneous cluster. We have new code running with old code. The clients are completely oblivious to this difference. Everything is, again, forward and backward compatible.
I was going to ask you about that. If the user has to have all of their requests rather than either one version or the other.
No. The only case where that matters, so for a backend system it doesn't matter. The only case where it matters is for the front end, because you don't want a user to see one version of the website and then the old version and then the new version and then the old version each time that he refreshes the page.
So the front end knows which one of those to contact based on the functionality that it requires. So say you added a new
Based
feature,
on
you-
user context. So
Right, if you added a new feature, obviously you can't use the old PMs that don't support that feature.
you'll make sure to release first, the backend, kind of the leaf servers, and kind of make your way through the website. What I mean is, let's say that the homepage has a different text. Like you change, the marketing text on that homepage. What you want to avoid is having one customer, as the release goes on, there's 5 or 10 front-end machines. You don't want them to hit different versions because they would see the text flipping from the old language to the new language and back and
Right, I was
forth.
talking about a more substantive change. For instance, you have a new feature that's something entirely unsupported by pieces of the old backend. So if the user is upgraded to use the front end, obviously to take advantage of the features exposed in the front end, you're going to have to
Right.
not use certain parts on the back end.
Yeah. So that's a great great question. So releasing a brand new feature, for instance, a new kind of orders or something that's really completely new. So what will happen is we'll release that in the back end. We will typically even let it bake like a full day, play with it manually, and then deploy systems that depend on it later on to make sure that as we deploy systems that depend on that, we will never have a rollback. And so when we deploy, we have, our biggest cluster is 11 instances. We deploy the first one the way I just showed, and then we exponentially increase the groups that we're going to deploy. So we start with 1, then 2, then 4, and we increase the monitoring. We self-test the machine, and we make sure that rollbacks are fully automated.
So if you're exponentially increasing the group sizes, how are you handling scaling and load to go through that? If you're taking down 50% of your cluster through deployment, how is the load going to be evened out for that?
Yeah, that's a great question, load. We don't have a lot of load.
Okay.
We're, you can compare us to a bank's website. And so we are very focused on having very high availability, but we are not so focused on scalability. For stability, as you're taking machines up and down all the time, you have to cluster everything. You want as little global state as possible, and the only global state in our system is kept in Zookeeper. And again, monitor everything. And when we mean monitor everything, to go back to having kind of a proportional investment, you want to make sure that you monitor at least the minimal amount. Is the machine still alive? And for many of our services, that's sufficient because the self-test and all of the other testing captures enough of the thing that if the service is actually up and running, we're kind of pretty sure that it's correct. And again, the implementation all uses tools that are available out there. We package our system as RPMs, and we use very standard DevOps kind of monitoring tools, Nagios, JMX, really off-the-shelf systems. That's kind of the main UI that controls all of the deployment system. It's a deployment manager. And so it basically captures on one screen all of the different parts that engineers have to be concerned about at all times. One is, the latest commits. What did we check in recently, and who is working on what in the team? We have the little, green means that the build was green on that version, and red was bad. Then we have Hudson, which is our continuous integration system. Basically the build that is compiling the code and testing it at all times. The build takes on average 3 minutes. And so you can see, the last that was completed, and the left that was successful. Here, they're all the same. Then there's a quick view at the cluster status. We color code every machine. Green is the machine is working correctly. Yellow, something seems wrong. And red, the machine is completely down. Emergency, someone needs to look at it. And then we have active deployments. Basically, we have a deployment queue, and we can see things, how they progress. Here, we're deploying 2 machines of the historical ticker feed, basically the pricing system for historical data. And so we have 1 machine that's up, that was self-tested, that is back in production, and now the 2 others are being deployed. And then we have a persistent log of every deployment that was successfully completed, which is how we can also do some statistics, one of them being the chart we showed. Here, it was a particularly bad day. We had 2 rollbacks, pretty close together. Now, these rollbacks affected the user experience in total about 30 seconds. So, it's very bad. It's something that we should avoid at all costs. But it's much better to have the site go down 30 seconds than an hour. Our money. Yep.
If you don't mind, one quick question on that. Why, if you guys are rolling out piecemeal, why would you need to take the site down at all? You just roll back the one, roll back circle.
Well, you might be halfway through your deployment, and then you roll back everything, and we do not take the precaution of alerting everybody to stop sending traffic. We just take down all the machines and go back to the previous version. So it's a very destructive process. The goal being going very quickly to a safe zone. Really risk mitigation.
How many rollbacks would you say for every successful ones? In there, it's not a good percentage, but over a period of a few months, for every 10 releases, how many rollbacks would you say you do?
Maybe 1 in 50, something like that.
You're almost doing 1 rollback a day.
1 every 2 day. Yeah. Yeah, I think that's. Yeah, we prefer having business metrics when we monitor. Yeah.
Yeah, I had a question. Are you using Zookeeper for both your system and your software global state? And actually, follow on to that is, do you use that? How do you do your deployments of your Zookeeper and management of that the same way as everything else?
Yeah, that's a great question. So we use Zookeeper mostly for cluster management. We also use it for synchronization between machines. So for instance, we have batch processes, things that need to run nightly. These machines, there might be 5 of them, need to elect a leader who's going to run that. And Zookeeper is a perfect place to do that. The deployment manager can release itself. So the deployment manager will basically start a deployment and then using Zookeeper, put enough state so that the other deployment manager takes over as the master, monitors the other deployment manager that is now become the slave, gets it back up, and then they kind of switch roles again. The other one becomes the master, and one becomes slaves, and it deploys the new version. So to answer your question of how we do self-deployments, essentially.
So you also have a test suite for your deployment management?
We have no test suite for the deployment manager. We have unit testing. It's still test-driven development, but the self-test and the monitoring on the deployment manager is pretty minimal because it's if the deployment manager is down, it has no business impact, and so it also never went down, and so we don't want to over-invest early on if there is no need. And every engineer looks at it really all the time. So, people would be shouting like, "Where's my DM?" Yeah, let's speak about end-to-end monitoring, which is an interesting topic. The the front-end testing is always one of the hardest to achieve. And the solution that we settled on is having a canary. So we'll have 5 front-end machines plus 1 that is only there for front-end testing. And we'll have a number of browsers running against that at every deployment. We also have a Keynote-like service which looks at our system and gives us some metrics on how the website is doing overall. When we look at this portfolio manager's page, do we have his name showing on the page? If the name doesn't show, the page is probably rendered incorrectly. So let me speak a bit about some of the future developments that we have in mind. It's a target that is always moving.
Actually, before you do that, quick question on deployment. When you have an underlying data architecture change, do you handle that in a special way, or do you just kind of do old school type, we'll change the architecture and then we'll release it at 2 in the morning?
Do you mean data schema change?
Data schema change, yes.
So we will roll out the data schema well in advance of the new services running. So
And make it backwards compatible?
And make it backwards
Okay.
compatible.
Thanks.
So if you want to drop a column, it'll take you a few steps. You want to deploy new systems that don't use that column and then remove that column.
But it's still fundamentally the same deployment?
Fundamentally the same concept, yeah. And important to note, database schema changes are applied manually. And the reason for that is a database schema change will lock the database. So you need to have some smart about when to do it. It might be something we automate in the future, but currently we have no plan. These are rare enough that we're very happy. Just someone raises and please don't release the system. Let me apply the schema change, and we kind of do it in an ad hoc way. So there's kind of 2 developments that I want to speak about. One is quarantining, which is very similar to the canary idea of the front ends. We want to be able to, as we deploy the new backends, quarantine them and then send only testing traffic to them. So basically, use the site with special headers that say, oh, I'm a tester. I'm using the site for testing purposes, and have this information flow through the whole system, such that when it gets to a service that might be 4 or 5 or 6 hubs behind, this information of the testing context is still preserved, such that we can look at the overall website and how it reacts to real deployment changes. The other one is being able to describe our infrastructure. Currently we have enormous amount of configuration files and a lot of duplicated configurations. We have Nagios has its syntax, JCollectly has its own. We use Puppet, which has, again, a 3rd syntax. And it's extremely easy to get those things out of sync. And it's completely contrary to proper software development, which is don't repeat yourself. And so it has happened in the past that we get a new cluster up and we actually forget to monitor it. And the first time it goes down, everybody is like, oh, but we didn't get a pager. How come it wasn't even caught? Or you introduce a new database schema and you forget to back it up. These things are the kind of errors that we really want to avoid by design and not by process. We'll be organizing a TGIF at our office in August. We gave a talk that was pretty similar a month and a half ago at LinkedIn, and we had a number of requests to meet all of the other team members. So if you want to come, we'll probably announce it on our Twitter accounts, and otherwise, just send me an email, pascal@kaching.com. And I've also put a list of references of what we consider very interesting readings testing blogs, the Google blog, the Google testing blog, and other resources on extreme testing, our blog, and other resources which are interesting and kind of go more in depth than in what I've presented here.
This will all be on SlideShare, and I'll send out a link to the presentation as soon as it's to everyone on the mailing list. So I guess we'll open up to questions.
Yeah, absolutely. Yeah.
Pascal, very interesting talk. Thank you very much for sharing. Could you talk a little bit about how you migrated from when you joined to where you are today? You know, probably starting with a smaller team, not all these practices in place, and you know, what were the first things you tackled, and
So-
the learnings from that?
Yeah, so the first thing we...
Can I add something to that?
Yeah.
I'm going to ask a similar question. When you're starting out, obviously doing this full-blown system would add a lot of drag up front.
Yes.
You want to get out your MVP. So if you could also describe from the very beginning at what point you added things and what do you think was the most important thing to start with?
Yeah, yeah, and so it is a very gradual process. What we're showing here is 3 years of work and things being added one after the other. Where it all starts is the drive to actually get there. If you don't really want to get there in a really long time and know that it's going to take you a really long time to get there, there's no way to even start. Test-driven development for me is the most important software development practice that empowers continuous deployment in the long term. And so that's really where we would start. In the first 3 weeks of the company, we were really busy writing code. We didn't have a continuous integration system. We didn't have a build. And that was kind of the first thing we did. And it wasn't actually engineers on the team that did that. One of my friends from Google spent 10 hours with us and set up the system so that we would get a very basic continuous integration system. If you don't run your tests all the time, they're invariably going to be fragile, and invariably they're going to be mostly failing because no one is aware that they should run the test and that it breaks. And so these were kind of the two first steps that we took. Later on, we decided to package our software in a pretty standardized way. So we decided, well, we're going to use a common infrastructure for all of our different services, and because we do that, we can package them in a very easy way. And we're going to spend the effort, the 4 or 6 hours that it takes to actually write, a proper kind of packaging system to be able to get it out to production in one go. And so, these are kind of the first few things we did. And as the team grew and grew, the need for visibility into the production system became more apparent. So, 6 months ago, we didn't have the deployment manager UI to look at how things were going. We were 6 engineers. We had command line scripts that would, take one package and deploy it everywhere, following the same kind of process, but there was no UI. And so, at each step, you kind of want to try to address what is the biggest pain point. And the way the DM was created was actually an engineer being really frustrated with the script tools and being like, I'll just spend my weekend building a nice UI. And then when it's out there, everybody wants to contribute. And on a slow day or at 6, get your soda and code a little bit on that system to kind of relax at the end of the day.
I have a question about migrating to test-driven development. So if you have a team or a code base, do you believe it's possible to migrate to test-driven development, or do you really think it has to start from the beginning of a code base?
No, I wouldn't say. That would be a pretty sad statement. I think dealing with legacy code, and what I mean by legacy code is code that is not tested. It's not old code. It's just code that's not tested. You want to start really small. So maybe the new things you're adding are going to be tested. And from this day on, you have the methodology to say, well, at least 20% of what we create from today is going to be properly tested. One of the key things in moving to test-driven development is actually learning how to test software. And it's not trivial to write testable code. You really want to go to those blogs and kind of learn, standard pitfalls that people fall into that makes the software untestable. With code that wasn't built from the start with testability in mind, it'll probably be, very hard, even for an experienced tester, to jump in and test everything. There will need to be some refactoring that's going on. And so, start with new code, fresh code. It's always easier. Make sure you get a good hand on what are some of the practices and some of the patterns that help in getting to more testable code. Separating concerns, delegating versus extending, kind of software patterns that lend themselves to being more functional in the sense of functional programming. And then for the legacy part, try to isolate little components. And what is really hardwired, like this little piece actually talks to the database directly, and there's no way to hide it. Well, maybe put that in a very small interface that is only going to be doing that, and kind of incise just around this thing that is impossible to test. Stored procedures, if you use SQL Server or Oracle. There's no way you'll ever test that, with a small team. So, separate that, put an interface around it, and fake it in your test. Yep.
So you said about 6 months ago you had 6 employees that were using this system. How many do you have now?
We're 11.
Do you think there's any particular languages and or frameworks that are more conducive to this approach, test-driven approaches, or just from your experience? The answer could be
I
no or
don't
don't know.
think so.
Okay.
As a compiler person, I would say that languages are simply sugar on top of core programming paradigms. And the programming paradigms, there's not a lot out there. There's functional, there's object-oriented, there's logic programming. These are kind of the core three. And then every language kind of mashes up some of those features here and there. And so I don't think that any of the test-driven development ideas are better captured by this or that language.
And a second question, what do you think, just speculating, or you can, don't have to answer, but what do you think the impact of NoSQL languages like Mongo or something would have on this type of approach versus, like MongoDB versus a MySQL database?
I
No
think
impact?
that, it all comes down to isolating third-party code. And MySQL is a storage device, just like a hard drive, or like Memcached, or like an email server. These things are third-party software. You're testing. What you want to test is interactions, and testing interactions, be it with a MySQL database or a Redis database or a MongoDB, is really the same. It's exactly the same, the same patterns.
Well, what do you think about possibly using a schemaless database to make sure you don't have the lock?
So in many places in our system, we have very strict ACID properties. If we give you 5 shares, we must take your money. And so we cannot move out of the ACID world. There's some places where we don't really need that, and we will denormalize the data in Voldemort. But many places, we are really tightly integrated with those properties that the database provides.
Isn't that a separate issue from having a schema then? For instance, you could just lock one user account and upgrade that user account, but then move on to the next one, correct? Without requiring the schema changes across all of their accounts.
I see what you mean.
So you don't have to stop the world when you use it.
Yeah. Well, there's some places where we store protobufs directly in the database. So basically a big blog to address that. So we don't always normalize the data in the database. But currently we have no plans to moving out of MySQL. Yeah.
So you've grown from 6 to 11 developers using this continuous deployment approach. It seems to me the linchpin of being able to do this is that you have a lot of faith in the developers themselves to basically do the QA because you've taken out the QA people and to handle all the corner cases in their testing. So do you worry as your organization grows larger or if a larger organization try to implement this, how you handle people management, hiring people who do really good tests?
Well, there's a number of answers to that. I think the first one is to understand that testing at KaChing is not optional, it's a job requirement. It's really something that's core to how you write software. The same way that an engineer at Apple who doesn't write code is not very useful. An engineer who doesn't write tests at KaChing is not very useful. And a lot of it is mentorship. You want to have, when the person starts in his first month or first 2 months, you want to have a mentor that's going to help write more tests and show the advantages of test-driven development. And I'd say for young engineers, we would do the mentorship, but you would never hire a senior software engineer who doesn't believe in testing. If there's an animosity from the start, it's just not a right culture fit. Yep.
Yes, two questions. One is, do you collect and measure productivity of individual developers? Will you go to assess their performance, compare once against another, against the team? If yes, what are those metrics and how did they evolve? What were the steps, what you started with and where you came, and maybe some notes on what's the ideal dream state of that? The second one is, what's the balance of effort that goes into the development versus QA, which is from what we heard about is pretty independent. Is it 80-20 or?
So let me answer first about metrics on developers. We don't believe in measuring people with numbers. We have an amazing team. Everybody works extremely hard. We all own a very big part of the company, and everybody works extremely hard on the system. And we don't believe in having metrics to judge how engineers do their work. If you introduce metrics, people will start optimizing for those metrics, which are only a very far proxy for what you're trying to do. Let me give you an example. We have a number of static analysis tools in our system. Coverage analysis, the number of warnings in this or that piece of code. We don't, these are nice to have, but they're very far from what we're trying to achieve in the long run. And there's not one metric that can capture the complexity of where we want to be. And introducing too many metrics and being too metric-driven in software development really kind of creates the wrong incentives. Now, the second question about balancing QA and development, in our mind, these two things are indistinguishable. There's no development without testing. These two things are completely integral. We have this project Koala, and we have a number of other open source projects. You can go and look at how our commits look. There's never a new feature without a corresponding test.
Right, but overall, do you have an independent QA team that
We
does?
do not.
So everything done by developers?
Yes, we have no QA.
I think we're going to stop it there, and if anyone has any additional questions, hopefully you can stay around for a few minutes.
Absolutely.
So let's all thank Pascal.